and welcome to the video solution guide for exam 1 for Math 117. So this video is appropriate for my Monday and Wednesday classes, my 8 a.m. and to 9:15, and also my 1 p.m. to 2:15. You guys had the similar enough exam that I can do one video for both of you, which is great. So in this video, I'm going to walk you through just the solutions step by step, and you're going to be able to see your mistakes and make some corrections. So problem 1, I was really proud of the answers you guys had. I just asked you for 2 points. What's one mathematical skill you've improved in the last 6 weeks? You mostly talked about fractions. Some of you talked about just kind of studying or just improving your general relationship with math. One thing I've noticed across the board for our classes, and this is both of them, is improved problem solving. I've noticed that we're more willing to take risks. We're more willing to try to make mistakes. We're more willing to just kind of take a stab at different things. So that's one thing I noticed I'm pretty proud of. And let's get into problem 1, or problem number 2. So problem number 2 says, after applying a 7.5% tax rate on the price of a shirt, the shirt's final cost is $38.24. What was the price of the shirt before the tax was applied? So a couple things to note in this problem. Before the tax was applied. So that tells us that we're looking for a price smaller than $38.24 because we're looking for what the shirt cost before we apply the sales tax. So to solve this, what I would say is okay, let C be my cost before taxes. I'm going to change my pen. I think that's a little hard to read. So C is my cost before taxes. So 0.075 multiplied by C would be the amount of tax. So to get the price of my shirt, I would have the cost before taxes plus 0.075 C. And that should equal our final cost, $38.24. So then I can say 1.075 C should be equal to $38.24. And then I want to divide both sides by 1.075. So I'm pulling up my calculator. And I'm going to take 38.24 and divide that by 1.075. And I get C is $35.57. I'm rounding this to 2 decimal places because it's money. So that's problem 1, or problem 2. Problem 3, we were talking about a Venn diagram. So problem 3 says we surveyed 100 students, 60 take English, 40 take math, 50 take chemistry, 30 take English and math, 35 take English and chemistry, and 25 take all 3 courses. So construct a Venn diagram that organizes this information. And then I wanted you to tell me how many students are taking at least 2 subjects and to shade the area of the Venn diagram that gives you this information. So most of us started out pretty strong with a Venn diagram, right? We have 3 circles because we have 3 overlapping. I'm going to zoom in here a little bit. And so the first thing you want to start with here is your 25 that take all 3 courses. So that's the first thing that I'm going to fill in. 25 take all 3 courses. So I know that 25 here will be in the middle. Let's go ahead and label these two. Let's say that over here we have math, and over here we have chem, and over here we have English. So we know that 25 students are taking all three. So 25 goes right there in the middle. And now you want to work backwards and take a look at the overlap, because we know total numbers, right? We know that in total we have 40 people that take math. In total we have 60 people that take English. Let's say E is 60. And we know that 50 people take chemistry. So if you look at these bubbles here, right now 25 people are in the overlap. So that overlap is also contained in the chemistry bubble, right? So in the rest of the parts of the chemistry bubble, here, 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 whatever numbers I put in there, when I add them to 25, they're going to have to give me at most a total of 50, because there are 50 people in that chemistry bubble. So that's what I'm going to do. I'm going to use the information of the problem to kind of work backwards. So now I know 25 take all three. So the next fact I'm going to look at is that 35 take English and chemistry. So I have 35 students that are going to take English and chemistry. This is the part of my graph that tells me people who take English and chemistry. So 25 people are already there. They take English and chemistry and math. And I know that there's a total of 35 people that take English and chemistry. So that lets me know that I need to fill this in here with 10, right? So now I have 10 plus 25. That gives me the 35 people that take English and chemistry. I'm going to move along and take a look. And I know that I have 30 people that take English and math. So let's go ahead and highlight that, right? I have 30 people that take English and math. Well, here is the region of the graph that talks about English and math. And so 30 people take English and math. I already have 25 people in that region. So I'm going to go ahead and fill in 5 here. So now I have a total of 30 people who take English and math. And so now we're going to keep working backwards. And we're going to say, okay, I've got my 35 people who take English and chemistry. I've got my 30 people who take English and math. I've got my 25 people who take all three. Now it's time to fill in the rest of these bubbles. So we know that there are 40 total people who take math. So in our math bubble, we should have 40 total people. I see right now we have 5 and 25, so that gives us 30. So if I'm going to have 40 people total, that means I would have 10 right there. For English, I have 60 people total. And so this is my English bubble. So I have 10 plus 25 plus 5 people currently in the English bubble. So that gives me 40. So I know that outside of that region, I'm going to have 20. And that gives me my total English bubble. And in chemistry, I know that I have 50 people who take chemistry. So already in my chemistry bubble, I have 35 people. So that's going to give me a total of 15 people for chemistry. Okay? So then what I want to do at this point is I want to add up, because we surveyed 100 people, and I want to see sort of how many people are taking these classes. So I'm going to double check all my information, make sure I have 50 people in chemistry, 10, 25, 50, yeah. I've got 40 people in math. I've got 60 people in English. My overlaps look good. So how many people total are in this Venn diagram right now? I'm just going to go through and add, and I'm going to say 10 and 5 is 15, plus another 15 is 30, and then plus 10 is 40, 50, 60, 70, 85 people in this diagram. And I know that 100 people were surveyed. So that means 85 people were taking some of these classes, right? But there were 15 people out here in the universal set who didn't take any of these classes. They're not taking English, they're not taking math, they're not taking chemistry. Okay, so this would be a Venn diagram. This would be a perfect Venn diagram that would get you full credit. The biggest mistake I saw was people were double counting numbers in the Venn diagram. All right. And so now the second part of the problem says, tell us how many people taking at least 2 subjects and tell me what region of the graph will tell you that. So I've used a lot of colors here. It's getting kind of crazy. But if I'm talking about the region of the graph that's going to tell you everything inside this area would tell you people who are taking at least 2 classes. So everything inside that red shape. And so what do we have inside that red shape? 10 plus 25 plus 5. So we have a total of 40 people that are taking all of those classes. So that's the Venn diagram problem. Let's move on. And just feel free during this video, you guys can pause it, you guys can fast forward it, you guys can skip around, whatever makes the most sense to you. In this problem, we have a store for problem 4 that has clearance items that have been marked down by 20%. They're having a sale advertising an additional 45% off of clearance items. What percent of the original price do you end up paying? So for this problem, we want to know the original price. What's the percent of the original price that we end up paying? But they don't give us an original price. So we're going to make up a price. Let's say the price of something is $100. And we're choosing 100 because we're dealing with percents, and 100 is a nice number with percents. So first, we're going to deal with marking this down by 20%. This is our first discount. So I'm going to take 100, and I'm going to subtract 0.2 times 100. Times 100. This number, this 0.2 times 100, represents 20%. So if I do that, I get 80. So that's my first discount. My second discount takes an additional 45% off of clearance items. So I have this $80 that represents my new price. This is the price I pay after my first discount. So now I'm going to use that to get my second discount. I'm going to take 80 minus 0.45 times 80. And that's going to give me $44. So now I know that I pay $44 out of my original price of $100. But what they're asking in the problem is they want to know what is the percent of the original price that you end up paying. So you might see this right away, you might not, but percent means out of 100 or the part out of the whole. So here the price that I pay is $44. So if I take the price that I pay and divide that by the original, that's going to give me my percent. So the price I pay is 44 out of 100, which is the same as 44%. So you end up paying 44% of the price. The meatloaf problem. The meatloaf problem. Let's chat, okay? We've gone through this a lot in class. I'm going to try to show you a way that might make it easier. Another method. This type of problem is really common in life. It's really common in science. It's really common in math. It's just like an everyday sort of problem. That's why I'm putting such an emphasis on it. So let's take a look at the problem. You need to make 5 meatloaves for a party. The recipe for 1 meatloaf calls for 1 3/4 cups of breadcrumbs. So you know the store sells containers of breadcrumbs with 4 2/3 cups of breadcrumbs in each canister. So how many canisters do you need to buy? Give your answer as a whole number of canisters. So for this problem, I gave no partial credit because we'd gone over it in class twice, and then we had it on a quiz once, and then I told you it would be on the final, or on the exam. So for that reason, there was no partial credit here. So you could have gotten some things correct in your problem solving, but I didn't give you partial credit until you got all the way there. So let's talk about how to get all the way there. I need to find out how many breadcrumbs I need, and then how many canisters I need to buy. So I have 5 meatloaves, and for each meatloaf, I'm going to multiply. I need 1 3/4 cups of the breadcrumbs. So I'm going to multiply these two numbers together, and you can do that by converting this fraction to a mixed number. So that's what I'm going to do first. So I'm going to take 5 times 7/4, which gives me 35/4. So this is the total amount of breadcrumbs that I'm going to need. Okay. In each canister, I know how many breadcrumbs are in each canister. 4 2/3 cups of breadcrumbs in each canister. So I'm going to convert that number to a mixed number. So 4 2/3, that's the same as 14/3. So I need 35/4 cups of breadcrumbs. There are 14/3 in each canister. So I'm going to take 35/4 and divide that by 14/3. And you guys can feel free to do that in your calculator if you like. In the interest of saving space and time, that's what I'm going to do here. And when you do that, you're going to get a decimal answer. You're going to get 1.875. But you can't buy 0.875 canisters, right? I tell you to give your answer as a whole number of canisters. So you're going to need to buy at least 2 canisters. You're going to round that up to the nearest whole number. It's a little bit different from the way we did in class. I hope that that is helpful to some of you. If you're not sure why I'm dividing, why I'm multiplying, how I'm changing these numbers, converting in fractions, this is something I want you to talk to me about. Ask me during office hours or ask me in class, and I'm happy to help, okay? So let's take a look at problem 6. You deposit $300 into an account earning 3% interest compounded annually. How much will you have in the account in 10 years? So the first thing you have to do here is choose your formula. There's a couple clues here. I have compound in the problem, so I know it's going to be compound interest. I am making one deposit, so I know it's not going to be an annuity. Annuities have multiple deposits. Compound interest savings accounts just have one big deposit. So I know then that the formula I'm going to use here is PN is equal to PO times 1 plus R over K to the N times K. And then let's go ahead and fill in our different numbers here. So what is that $300 deposit that we have in green? That's our initial investment. Our compound is compounding annually, so that tells us about K, that we're only going to have K is equal to 1. Annually means happens once a year. We have 3% interest, so that's going to go here for our interest rate. And then we have 10 years. So that's going to go here for our number of years. So plugging that in, we know that Pn is equal to 300 times 1 plus 0.03 divided by 1 times 10, or raised to the 10, multiplied by 1. I'm going to plug this into my calculator. I'll do a little simplifying step here. So that you can see what I'm working with. And then you just have to plug this into your calculator. Check with me if you're still having calculator errors or if you can't get this number in the way that I'm doing it. So for this, I got 403.17491 ... But I'm going to round this because it's money to $403.17. So that's problem 6. Let's take a look at problem 7. First, again, we have to decide what formula we're going to need. So again, I notice here that my formula is compounding monthly. So this is going to be compound interest. Now, this problem is a little bit different than problem 6. Because it's asking us how much we're going to need to deposit in an account now in order to have $6,000 in the account in 15 years. So assume the account earns 6% compounded monthly. The way I know this is not annuity is they say, how much do I need to deposit in the account now? That now phrase is what tells me that this is not an annuity. If it was an annuity, we could deposit regularly. So it would say, how much do you need to deposit every month or every week or every year? This says deposit right now, one large lump sum. So I know that I'm going to be using the same formula as problem 6, but I'm going to be solving for a different variable. I'll show you what I mean. Okay, so let's go through. So compounded monthly, right? That's what we highlighted in yellow. That means our K is going to be equal to 12. So we're compounding every month. We want to have $6,000 in the account in 15 years. So that's actually our PN. That's the number we want to end up with. 15 years tells us our timing. And 6% tells us our interest rate. So notice what we don't have filled in. What we want to know is actually this PO, right? That's what we're trying to find in the problem. Don't worry, just plug in what we have, all right? So we have $6,000 is equal to PO times 1 plus 0.06 divided by 12 raised to the 15 times 12. My first step, I'm just going to clean some stuff up, okay? I'm going to take that 15 times 12. Just going to give me 180. I'm going to take that 0.06 and divide it by 12. So I get PO times 1.005 raised to the 180. And now I'm trying to solve for PO. So what I'm going to do is I'm going to divide both sides of this little equation by 1.005 to the 180. 1.005 to the 180. And that's going to tell me, these numbers are going to cancel out, and that's going to tell me what PO is. So let's go ahead and punch into our calculator. 6,000 divided by 1.005 raised to the 180. And so that gives us PO is equal to 2,444.8945 ... But because it's money, we're going to round to 444.89. And that would be your final answer there. And that's problem 7. Let's take a look at problem 8. So for problem 8, part A was worth 4 points. And part D was worth 4 points. And then B and C were worth 1 point each. So there was a lot of partial credit on part 8. So that's why I give you that information. It might help you to know what I was thinking, why I did things the way I did. And let's just kind of go through this. So this problem says Samantha invests $13,000 into an account that pays 2.5% interest compounded quarterly for 25 years. So the first part A, just asks how much is she going to have into her account after 25 years. Again, we have to choose a formula, and we have some clues. Our interest is compounding quarterly. So we know it's a compound interest formula. We know it's going to compound 4 times a year. She's investing one large lump sum instead of small regular deposits. So that tells us, again, we're looking at this. Pn is PO 1 plus R over K to the NK is the formula that we're using. And the amount that she invests to begin with is her PO. Compounding quarterly tells us what K. We have an interest rate of 2.5%. And then we're going to fill that in and calculate it out. So we have Pn is equal to 13,000 times 1 plus 0.025 divided by 4. Oh, we forgot to say her N is 25 years because it's asking how much she could have in her account after 25 years. So we have 25 times 4. So if you punch all this into your calculator, you will get the right answer. If you're having trouble with calculator work, definitely come see me in office hours. I can give you some parentheses tips. We can make things work out for you. As long as you're punching the right thing into your calculator, we should be able to get the same answer. And so what we get I punched the wrong thing into my calculator, you guys. I forgot to divide my interest rate by 4. So I got a really big number. I got really confused. So 1 plus 0.025 divide by 4. And we're going to raise that to the 100 power. There we go. I got $24,240. And that's it, rounding. So that's her total amount that she has. For part B, a lot of us tried to calculate an interest formula to figure out how much interest she will have earned over 25 years. But you have to take a step back and kind of use your critical thinking here, right? The total amount that she has, this 24,000 here, that's her initial investment plus her interest, right? So I can say that $24,240, that's her initial investment, her PO, plus her interest that she's earned. So that means $24,240. Well, her initial investment is given in the problem, $13,000 plus interest. So if I want to know what's the interest she's earned, I'm just going to take 24,240 and I'm going to subtract 13,000. and I'm doing it in the calculator because I don't want to make a mistake on the video. And so the amount that she earns in interest over time is $11,000 and $11,240. That's the amount that she earns over time. So part B and part C have the same answer. And that's kind of what I was hoping you would see in this problem. So that's how much interest she's earned. There is a formula for actual change, which is you take your end quantity, your ending quantity, and you subtract your starting quantity. And so for us, the ending quantity is that 24,240. That's how much she ends up with her in her account. And the starting quantity, that's how much she invested, 13,000. So if you take the ending quantity minus the starting quantity, the answer you'll get is 11,240. That's her actual change in her investment. That's how much money she made over time, $11,240. Relative change says you take the actual change. There's a formula for this. We talked about it in the first couple weeks of class. So it says you take the actual change and you divide that by the starting quantity. So for us, the actual change is 11,240. And the starting quantity is her PO, her initial investment. And that gives you about 86% change, if you divide that out and convert to a percent. Okay, my friends, that's the mathiest math part. Problem 9, I saw a lot of really interesting things that you guys had to tell me. I really liked reading that problem. A lot of you talked about set theory. A lot of you talked about Venn diagrams. A lot of you showed me some of the fraction stuff that you've been working on. And I'm just really glad that I asked the question. It was very interesting to me. I liked what I saw. For problem 10, right, I asked you guys to talk about your study methods for the next exam. I'm going to give you guys some tips here. Number 1 is homework. Homework. Do your homework. Homework is studying for the exam. If you do your homework every week you are studying for the exam. You're preparing yourself in the best possible way. Number 2, I would say, is come to class. Come to class. Be on time if you can. Come to class as much as you can. We do good work in class. It's a good time to get your questions answered, right? On top of homework and coming to class, I'm going to say study with friends. We do a lot of group work in class, and I think it shows us, like, we make a lot of progress when we work together and put our heads together. So talk about studying with friends. See if you can make some time together, even if it's a group chat or a Zoom. You can answer each other's questions, and it's just like a lot more fun. Sometimes studying math alone can be isolating. The 4th thing I'm going to say is ask questions. So ask questions during my office hours, ask questions via my email, ask questions in class, ask a lot of questions. All right, work a lot, see what you can do. I think this exam was a little bit of a wake-up call for us as a class, and I think it's going to encourage us to do better on the second one. I think you guys are great. I hope this was informative and helpful, and I will see you next